Okay students, now we will do the activity to observe the physical properties of sodium, which is a metal. You all know that sodium is a highly reactive metal, so we have to store it inside kerosene or paraffin in the laboratory, and usually it is stored in a brown colored glass bottle. But at times we can also use a plastic bottle that is not transparent so that it doesn't allow light to go in to store sodium. I will open the bottle. You can see that there is paraffin inside. Now I will take out a small piece of sodium from the paraffin liquid and place it on the white colored tile. Here you can see this is the sodium that has a small amount of paraffin around it, and you cannot observe the shiny surface. Although it is a metal, it's not shiny because it's very reactive. It's a very dull, tarnished surface. But as you know, sodium is a soft metal, so I can cut it using a knife. Now, when I cut the sodium, I will hold it and cut it into small pieces. If you observe the cut surface, you can see it has a shine. And with time, as you observe it, the shine will decrease and finally it will completely go off. To that extent, sodium is very reactive with air. So, as you have observed students, sodium, because it's a metal, it does have the lustrous nature. It has the shiny surface which we call the luster. But because it is very reactive, the luster or the shine is lost very quickly. And also you saw that it is a soft metal because I was able to cut it with a knife. Okay students, now we will do an activity to observe the chemical nature of sodium metal. That is the reaction of sodium with water. As you know, sodium is a very reactive metal. So normally it reacts very fast with air and it tarnishes. I have a small piece of sodium on the tile which I took out from this bottle in which sodium was stored inside paraffin. And as you know, we can cut sodium using a knife because it is a soft metal. And when we put it into water, there are many observations that you can see. In order to make the observation more clear, I will be adding a few drops of phenolphthalein, that is the indicator, which will become pink in color. Phenolphthalein is a colorless solution, and when it is in contact with a base, it will become pink in color. So when sodium reacts with water, it will evolve hydrogen gas and the solution will become basic. So that when I add phenolphthalein to water that is inside the trough, you can see the observation clearly. You can see it's a colorless solution. I am adding just 2 drops of phenolphthalein. And also you might be wondering why we are using this huge trough. As I said, the sodium reacts very fast with water. So we will need a large space and a lot of water so that vigorous reaction doesn't lead to any kind of explosion. And also to be safe, I will be wearing the safety goggles. And now this is also a large piece that if we put that into water, it might lead to explosion. So to avoid that, I will cut it into smaller pieces. Observe the changes when sodium reacts with water. You can see the sodium metal going around, moving because of the evolving of hydrogen gas, and also you can see when it moves around the pink color of the solution forming. So when sodium reacts with water, it evolves hydrogen gas. So students, you saw the observations. What were they? Sodium floats in water because it is less denser than water, and it reacts vigorously with water. That is why it moved around very fast. The movement was caused by the evolving of hydrogen gas. And as a result of this reaction, sodium hydroxide formed, and the sodium hydroxide gives pink color with phenolphthalein indicator. And again, we can confirm that there is sodium hydroxide, that is a base, using these two papers which I have here. You are familiar with these two papers. This is a red litmus paper and this is a blue litmus paper. Now with bases, the red litmus paper will turn to a different color. I will use both the papers. I will show you the color changes. Now you can see this is a red litmus paper. If I dip it in water, now you can see the red color litmus paper has turned to blue color. So that confirms the presence of base in this solution. I will also test it with a strip of blue litmus. Here you can observe that there is no color change. The red litmus turned to blue, but the blue litmus does not give a color change. So with all these observations, you would have understood how the sodium metal reacts with water, and the observations are now clear to you all. Okay students, now we are going to observe one of the properties of magnesium. We'll be using magnesium strips that are available in the laboratory. You can see I have a few pieces of magnesium strip. If you look at this strip, you can see that it has a black color layer over it. It does not look shiny as it is supposed to. So what do? We take a sandpaper and we have to clean it. When you keep on rubbing it like this, it will become clean and shiny. I have already cleaned some pieces of magnesium strip. You can see the shiny nature. So that shows magnesium has the lustrous nature. And also magnesium can be cut into pieces. So using a pair of scissors, I can cut it into pieces. Already I have cut out some pieces. Now we will look at the chemical property, where we burn a strip of magnesium in oxygen using the Bunsen burner. For that, I will be using the goggles because I am going to burn magnesium. And also, I'll be holding the magnesium directly to the flame. Therefore, I will be using a pair of tongs to burn it. And the goggles I am wearing, or the safety glasses, are for the safety of my eyes. Now, I shall hold it directly to the flame. Observe carefully what is happening to the piece of magnesium strip. You can see it's starting to ignite and it is burning with a bright white flame. And once it burns out, you get the resulting white color residue. you can nicely observe the white color residue that has resulted from burning of magnesium. This is magnesium oxide. So, from this activity, students, you all saw the observations clearly. What are the observations? Magnesium burnt with a bright white flame and we get a white color residue as the end product. Okay students, now we will do the activity to test how magnesium reacts with water. As you know already, magnesium is a reactive metal. It is available as magnesium strips in the laboratory and the strip is usually oxidized and has a black color layer over it. We can clean it using this sandpaper. If you just place the magnesium on the table and rub it continuously, it will become clean. I have already cleaned a few pieces of magnesium strips and here you can see the shiny magnesium metal. And also it can be cut easily with a pair of scissors. Already I have cut out a few pieces of magnesium. First, I will do the activity using normal water. Water at room temperature. So, I will need a test tube. To that, I will take a small amount of water and into that, I will put a piece of clean magnesium strip. You can see because of the higher density, magnesium has gone into water, but you can observe clearly even when I rotate, there is no change taking place. You can nicely observe the surface of the magnesium strip. There is no change taking place. That means magnesium does not react with cool water. So, I will place it in the test tube rack and now we will see whether magnesium reacts with hot water. As you know students, if we are going to use the burner for heating, we can't use the test tube because that is made up of thin glass. So, I will need to use a boiling tube and also I will be using goggles or safety glasses for the safety of my eyes. So, I will take a boiling tube. Into that, we take a little amount of water. And to that, we can put a piece of magnesium. Also, I will use a test tube holder in order to clamp the test tube and hold it to the flame. And we can heat water. You should take care students when heating substances inside the boiling tube, we should make sure that we shake the boiling tube very slowly. If you just hold it directly to the flame, there is a possibility that there can be a breakage, cracking of the boiling tube. Although it's a boiling tube, you have to make sure you provide heat evenly. We will have to wait till the water becomes hot. Now you can see there are few gas bubbles being produced around the magnesium strip. And the magnesium strip is also floating because of the water being boiling. You can observe the gas bubbles around magnesium strip. As you know, when magnesium reacts with water, it will evolve hydrogen gas. So that means the gas bubbles around the magnesium strip are hydrogen gas bubbles. So here again you can observe the gas bubbles very clearly. So students, with this activity, we can confirm that magnesium does not react with normal water or room temperature water, but it reacts with hot water and evolves hydrogen gas. Okay students, now we will do the activity to observe the reaction of magnesium with acids. For acids, we use dilute hydrochloric acid. So you can see the label, it has been labeled as DIL HCl. That means it's dilute hydrochloric acid. We can do this activity in a test tube. So I will take a small amount of hydrochloric acid into the test tube. And we are going to test the reaction of magnesium with hydrochloric acid. As you already know, magnesium is a metal. It reacts with air and forms the oxide layer. And we can clean it and take the shiny magnesium strip. Also, we can cut it using a pair of scissors because it is a soft metal. So, I have already cut out small pieces of magnesium. I will take one of those strips and put it into the test tube containing hydrochloric acid. You can see immediately it reacts with hydrochloric acid and the gas bubbles are being evolved. Normally, when a metal reacts with an acid, it produces a salt and evolves hydrogen gas. So here the gas bubbles that you are observing is hydrogen gas bubbles and the reaction is somewhat fast. So students, observe carefully the evolving of gas bubbles, and if you listen, you can also hear the sound of gas bubbles evolving because it is a fast reaction. Okay students, now we will do the activity of burning sulfur in air. As you know, when sulfur burns with oxygen, it produces sulfur dioxide. That is a harmful acidic oxide gas. So because of that, normally we are not supposed to, or we avoid burning sulfur in oxygen and producing sulfur dioxide, which can be harmful to the environment as well as somewhat uncomfortable for the person who is doing the activity. But here, for you all to understand and see the observation, I will be doing this activity using the minimum amount of sulfur possible. So as you can see, sulfur is a non-metal that is stored in the lab inside a plastic bottle. When you take out the sulfur, you can observe it clearly. It is a yellow color crystalline solid. Here you can see the crystalline nature of sulfur, and make sure that you don't touch any of these chemicals directly with your hand. And also, since I am going to use the burner and heat or burn sulfur, I will be using protective glasses or what we call as goggles as protection for my eyes. If you are able to use gloves, that would be also better. I can wear the goggles over my spectacles. Right. So, I'll be using this spoon which has a handle that will not conduct heat to burn sulfur. So, I'm going to use this spoon to heat sulfur. This has a handle that does not conduct heat. So, it's easy for me to hold it to the flame, and I will select the smallest piece of sulfur with which you can observe the changes clearly. Now I will hold it to the flame. Observe the changes carefully. You can see the yellow color crystalline substance With time, if you observe closely, you can see at the bottom the sulfur becoming a liquid, and the liquid is dark brown in color. Now sulfur has completely liquidified. Now it will start burning. You have to observe closely and clearly to see the change. You can see now sulfur is turning dark, almost blackish in color. Then it will start burning. If you look closely, students, you can see the blue color flame. You have to look closely near the spoon around the sulfur area. You can observe the blue color flame with which sulfur is burning. That is how sulfur burns in air. It burns with a blue color flame and completely gets converted to sulfur dioxide.